morning. It is a real pleasure for me to be here, and I thank John again for the engagement several months ago, and to the IoT Foundation for inviting me over and giving me the opportunity to address you all this morning. It's a pleasure, and I'm grateful for the opportunity. My topic today is AI, more specifically adversarial AI, and how we can approach it responsibly going forward. And I'm going to begin with a different story, a story from life, which will help us kind of get into the topic, I think, in a useful way. So let's begin with the story of a falling watermill run in Pennsylvania. This is the architectural marvel that was developed a long time ago by the famed architect Frank Lloyd Wright in the 1930s, who introduced the concept of modern American architecture. And it's a real masterpiece of American architecture. It's really as a new way of approaching architecture by incorporating the building into the landscape of the locale where it is located. A unique approach. Very, very impactful. The architect came up with really out-of-the-world ways to present a new way of architecture and living. But unfortunately, even with masterpieces, sometimes it takes time to attain their place in culture. And the beginning of this project wasn't a smooth sailing. In fact, the project was commissioned by the Kaufman family in Pittsburgh, who was a wealthy merchant, and they needed an escape from the city because Pittsburgh at that time was an industrial town with not a very livable water and air. So they're trying to escape the city in southwestern Pennsylvania, which is where falling water is located, and they wanted to build this structure. But when they saw the new building, the owner, Kaufman, didn't like it. He said, "I can't see the waterfall from the house." And that was a problem. And of course, the architect responded, "I don't want you to just look at it. I want you to live with it, with the waterfall. I want you to live with it." And think about different approaches to the same problem, different perspective, different way of thinking about them. And so eventually, things got better. The family realized the value of the unique design that they were given to, and having owned it for many decades, they eventually gave it back to the public, donated it to the Conservancy Fund of Pennsylvania, and eventually it became even a UNESCO World Heritage Site, which is a testament of a remarkable accomplishment of humanity. And so where am I going with this story, really? Why am I talking about it? Well, to think about it, our challenge today is to learn not just to look at generative AI in general, but to learn how to live and work with it by balancing the risks and rewards it comes with it. And so we all want to have on this journey a trustworthy AI, to be working with a trustworthy AI. So what is a trustworthy AI? Witness define it in terms of 7 attributes. It has to be valid and reliable, meaning that it has to give you useful and trustworthy information. It has to be safe. You don't want to get from it toxic output and things like this that will harm you. It has to be secure and resilient, to be able to withstand attacks of adversaries on it. It has to be privacy enhanced to maintain the privacy of the data that's contained in it. It has to be explainable, interpreted. It has to be fair with harmful bias mitigated. And it has to be accountable and transparent. One way of thinking about it is like the famous duck test, right? If it looks like a duck, if it walks like a duck, if it walks like a duck, it must be a duck. So if your AI has these 7 attributes, then it must be trustworthy. That's one way to think about it. And of course, this is a very wide landscape, and I'm not going to be able to talk about it. I'm going to focus mostly about the security and the resilience aspect of of that spectrum. So bear with me for the rest of it, just thinking about mostly security and resiliency of the AI system. Okay, so one thing about the attributes of AI, we want to have always everything at max 10 on all 7 of them. Unfortunately, in this game, you cannot have it all. In fact, most of the attributes are in the relationship of trade-offs. If you improve on one here, you're going to give up on something there. So you have to sort of recognize that and think of ways to sort of come up with trade-offs that are acceptable to you, you as an individual, enterprise, or society. Of course, there are systematic ways that you can go about it, the so-called Pareto optimality that was introduced by an Italian mathematician in the early years of the 20th century. And it has to do with multi-objective optimization, where you try to improve on one objective without causing harm to another. So that gives you a systematic way of thinking about how you can optimize the trade-offs of trustworthy AI attributes. But bottom line, again, is that you have to think about acceptable ratios of your trade-offs and decide on the priorities depending on the specific AI system that you have, the use case, the various economic, environmental, societal, cultural, etc. issues that you're dealing with in the local environment where it's operating. Okay. So I'm going to start with a posit that AI is useful and fun, and I'm not going to spend much time dwelling on that, but I'm going to say it also comes with its own risks, and that's the part I'm going to be focusing on. And there's 2 kinds of risks in AI, the so-called inherent risks, and they have to do with unwanted bias, hallucinations, errors in the generated data, implementation flaw in the model or the platform where the model is running, etc. And we have developed at NIST several standards that deal with those issues. A couple of years ago or so, we issued a standard about identifying and managing bias in artificial intelligence. And recently, we introduced actually a secure software development framework, which is a companion for large language models. Because if you are thinking about AI and you're thinking about incorporating AI into your products or infrastructure, these models are not used as is. You have to develop software in order to integrate them in the specific workflows that are using them or how they used to assist your personnel. So there's a lot of software to be developed in order to incorporate them. Also, you have to connect them to additional data sources so that they can adapt to the specific subject domain that you're working with to operate in things like RAG or retrieval augmented generation scenarios and things of that sort. There's a lot of software development that needs to happen in order to incorporate these things properly into your infrastructure. And this second document actually gives you good guidelines on how to approach it systematically. But today, I'm going to be focusing mostly on adversarial aspects, and these are the deliberate actions by motivated and experienced adversaries aiming to disrupt, evade, compromise, or abuse the output from your models. That we introduced a new NIST standards earlier this year called NIST AI 102 edition 2023. And here's a view of the various, we introduced sort of a map of the landscape of attacks and mitigations. And one way to understand it is to look at it from the point of view of an attacker objective. What are attackers trying to do to your system? And there's 3 classes of attacks for non-generative or predictive AI systems that we have identified. Availability breakdown, where the attacker is trying to break down the system so it will stop operating the way you wanted it. Integrity violation, where they're trying to change the way the model predicts so that it obeys the attacker objective, but not what the initial the model designer had in mind. And finally, privacy compromise, when the attacker is trying to elicit private data related to users or to elicit the weights of the model, because sometimes the model weights are intellectual subject to intellectual property, and it's important to keep them confidential or secret. And so by them exfiltrating them, that's a privacy violation. On the generative side, we maintain the same three, plus we introduce misuse, where attackers are trying to repurpose the information that's generated by the model for purposes that are outside of what the designers or the owners of the model have anticipated. And so this is basically a very wide framework or landscape of risks and a potential for attacks. But the bottom line here is that I want to leave you one specific message here, and that is that machine learning models can be attacked at all stages of their life cycle, from the design, training, all the way to deployment and use. And so, so here is my next message. So how we go about it? Well, we have to embrace it. AI provides a lot of value, but we have to prepare to fail with it. And by that, I don't want to scare you, but simply to indicate that you cannot mitigate all the risks that come with the technology. So what you need to do is to develop a risk budget. What is the residual risk you're prepared or comfortable living with? And that's really how you should approach this problem. You have to be able to inspect the user input that's fed into the model, but be aware of the fact that there's limits on what you could do in practical terms. There is always, we talk about the guardrails that are introduced in the models and hope that they're robust enough, but they never really are. In fact, there are theoretical results that show that these guardrails can never be robust enough. So you have to do your best at inspecting the user input and mitigating all the risks that you can get your hands on. But be aware that this is sort of always evolving game of a cat and mouse. You have to monitor the runtime state of the system and try to detect failure modes or modes that are induced, bad modes that are induced by the attacker. And finally, you have to develop a plan for recovery from a breach. It turns out that organizations that are prepared have lower losses than unprepared organizations. And that's why in the top of the slide I said prepare to fail. Basically have a plan at hand that tells you what to do in case of a breach, and that will guide you better to escape with minimal losses as opposed to improvising on the spot. And so to do that in a systematic way, it's a good practice to follow the NIST AI risk management framework. That's another framework that we put out last year, I think. And that allows you to establish an AI governance organizations within your agency or enterprise. But importantly, you have to staff it with people who know AI from experience. It's not just enough to say, okay, I'm going to take some people and just put them there because they've heard about AI. It's better to have those who actually have experience with the technology to have an effective organization about it. And it's also a good idea to use the NIST generative AI profile if you are looking to adopt generative AI in your organization to allow you to fine-tune your organization, your corresponding risk budget, and management. One thing to caution about AI technology is that you have to be able to look past the demo. What I mean by that is that you can put together amazing demos with AI, but the thing is, deploying and using the system in the long term exposes its limitation. And believe it or not, this technology is limited. And by that I mean there is a definitive difference between cognitive task automation and cognitive intelligence. You and I have cognitive intelligence, but these systems are not there. All they're trying to do is automate a cognitive task. And there's a big gap between the two, and the long term will expose the gap. So look past the demo and think about the long term when you are adopting the technology. Be aware of the scale. We all in cybersecurity have been taught from the very beginning to think about the cybersecurity perimeter. Here is my enterprise, here's the perimeter around it, and I'm going to spend my time hardening it up. And we've more or less gotten better or worse, I don't know, but we've gotten used to that game. Well, AI changes it profoundly. When it comes to the large models that are used in AI, the scale is unprecedented. Your security perimeter is essentially the internet as you know it. And that's really hard to defend. So you have to apply all the tools that you have to perform data sanitization in order to clean up the data and manage it to the extent possible to train your data model, your machine learning models or AI systems. But be aware that sanitization is necessary, but it's difficult to achieve in full. There's actually theoretical limits that tell you that there is no algorithm that can guarantee a robust sort of filtering of potentially harmful inputs that go into your AI model. So in particular, it's well known in physics, but now people have proven it in AI that you cannot easily detect out of the distribution input as long as the two distributions, the normal and the anomalous distributions, overlap. So if there's some overlap, you're out of luck, and that's where your tools are going to break down. Therefore, there's always going to be a place for an attacker to hit you if you are relying blindly on tools. So use the tools, they're important. You cannot sort out your data by a naked eye. It's too big, it's not feasible, but be aware that that's not the end. You have to know the provenance of your data and AI system, and that's not a new statement. Everybody who's dealt with cybersecurity knows that you need to know the provenance of your systems, except that the supply chain of AI comes with its own even harder problems to deal with, I think. First of all, it's very difficult to detect backdoors in AI systems once they're planted. Harder to do that in AI than traditional software systems for many reasons. We don't have the time, but I'm happy to chat. I'll be around for the rest of the day. So traditional checklists for system health do not work, especially for those generative models that are stochastically based. Supplying the same input twice to them give you two different answers anyway. So you can't think of a checklist, simple checklist. You have to think of the problem differently in a much more comprehensive way. You have to train your employees. For example, people like to use coding assistants to improve or increase the productivity of their engineers, and they can be useful if they're properly used, but you have to be aware of the so-called over-reliance on AI and to know exactly the provenance of your assistant. Why? Well, there's already well-known attacks on generative models that are used to assist in code development that can implant malicious functionality in the model to allow it to generate vulnerable code that can be triggered on demand by an attacker. So imagine, and then it can be camouflaged so that on a normal day it will behave normally and give you robust code or secure code. And imagine people trying to use this assistant over time, get over-reliant on it, attacker flips the switch, and all of a sudden they accept vulnerable code. And this is not a hypothetical, it's a real threat that can happen. That's why you need to know who's done what to your coding assistant, where it came from, is it trustworthy or not. So with that, I'm going to end up with a question, AI friend or foe? Well, it depends how you flow. So with that, let me wrap it up, and open it up for questions if we have the time.